All right, let's just go ahead and forget the sci-fi stereotypes for a second. You know, the metallic robots taking over the world. Yeah, artificial intelligence isn't magic, and it's definitely not science fiction anymore. Honestly, it's just really, really beautiful math that is literally already powering your life. So, welcome to this explainer. Today, we're taking a guided journey through the AI universe. And if you're a student, or really just a focused learner looking to build a career in tech, you can consider this your foundational roadmap. We're going to break down exactly how machines learn, how neural networks mimic the human brain, and most importantly, what tools you actually need to start building these systems yourself. Let's get into it.
Think about it. You are already interacting with AI every single day, probably before you even leave your house. When you glance at your phone and Face ID unlocks it, that's computer vision. When Google Maps or Uber routes you around a massive traffic jam and predicts your exact arrival time, that's AI working behind the scenes. It's the engine deciding what you should watch next on Netflix, and it's the reason your Gmail miraculously keeps all that annoying spam out of your primary inbox. So it's not some distant future, it is very much the present.
So here is the structured roadmap we'll be following today to unpack all of this. We'll cover 1. Welcome to the AI universe. 2. How machines actually learn. 3. Grouping data and earning rewards. 4. Inside the deep learning brain. 5. The generative AI revolution. And finally, 6. Your next steps in AI.
Starting with Section 1, Welcome to the AI Universe. And the subtitle really hits the nail on the head. It's already everywhere.
To make sense of all this, imagine AI as the largest of those wooden Russian nesting dolls. At its core, the crucial point is that AI is simply a machine mimicking human cognitive tasks. See, as humans, we are naturally great at looking at data and finding patterns, right? We easily understand context when someone speaks, or we can just glance at an image and instantly recognize a car's license plate. Well, AI is just the broad umbrella term for the technology that allows computer systems to perform those exact same human-like tasks, whether that's understanding speech like Siri does, or recognizing an object on a busy highway.
Moving right along to Section 2, How Machines Actually Learn. This represents a massive paradigm shift. We're opening up that next Russian doll and transitioning from general AI into its most important subdomain, machine learning.
Now this right here, this is the ultimate paradigm shift in computer science. In traditional programming, a human sits down and writes the logic. You feed the computer an input, it runs through your hard-coded rules, and it spits out an output. Pretty standard. But in machine learning, we completely flip the script. We feed the algorithm both the inputs and the outputs. For example, we give it thousands of past bank loan applications along with whether they were approved or rejected. Then, the machine figures out the logic itself. It learns the hidden patterns from the data to create its own model. No way, right? It's brilliant.
To keep things organized, let's break down the 3 distinct pillars of machine learning so you can map out exactly how these algorithms actually digest their data. First, we have supervised learning, where the data is perfectly labeled. It's basically like a teacher providing an answer key. Second is unsupervised learning, where the machine gets raw, unlabeled data and has to find the patterns on its own, kind of like exploring a dark room. And finally, reinforcement learning, which is all about maximizing rewards through trial and error, very much like training a dog with treats.
Let's drill down into that first pillar, supervised learning. Within this space, models generally solve 2 types of problems. They either classify things into strict, predefined categories, like checking an email's keywords to predict if it is spam or not spam, or deciding if an image is a cat or a dog. That's classification. Or they run a regression to predict a continuous numerical value. You know when you order food on Zomato and the app predicts it'll arrive in exactly 14 minutes based on your location and past rider data, that is a regression model in action.
Okay, Section 3, Grouping Data and Earning Rewards. Finding hidden patterns. Let's see what happens when we don't have perfectly labeled data for our machines to learn from. Unsupervised learning basically acts as a master organizer. Imagine feeding a system thousands of online news articles without telling it what a single one of them is actually about. The model will just automatically find hidden connections and cluster them together into groups like sports, technology, or politics. It's also exactly how e-commerce sites do market basket analysis. The system notices that users who buy bread also tend to buy milk, so it just starts suggesting milk to you automatically. No human guidance required. And then we have reinforcement learning. Honestly, think of this exactly like training a puppy. If you want a dog to sit, you reward it with a treat when it does well, or you give it a gentle penalty if it, say, chews the rug. We train models, which we call agents, the exact same way. The agent makes predictions or takes actions in an environment. If it makes a good move in a game of chess, it gets a mathematical reward. A bad move gets a penalty. Over time, its only goal is to maximize that score, and that is the exact math used to train self-driving cars and complex robotics.
Moving to Section 4. Inside the deep learning brain, mimicking the human mind. We're opening up our next nested doll here, stepping into the highly advanced territory of deep learning, where algorithms take heavy inspiration from the structure of the human brain.
So why do we even need deep learning? Well, traditional statistical machine learning is great at reading neat, tabular data, like a well-organized Excel spreadsheet. But the vast majority of the world's data, like 80% of it, isn't in neat little spreadsheets. It is messy, unstructured data. We're talking billions of YouTube videos, audio recordings, and random text messages. Traditional models really struggle here, but deep learning absolutely thrives at extracting features from all this raw, messy data.
Deep learning relies on what we call artificial neural networks. And training one is basically just a massive mathematical trial and error loop. Think of a college calculating your final grade. They assign specific weights to different things, maybe 40% for the final exam and 30% for midterms. In a neural network, data flows forward. The model applies mathematical weights to guess an outcome, and then it checks its error against reality. Then, in a step called backward propagation, it goes in reverse, adjusting those weights to learn from its mistakes so its next prediction is smarter. Over time, these neural network architectures have evolved to handle very specific data types, and it's led to incredible leaps forward. Feed-forward networks handle basic tabular data. Then, recurrent neural networks added a form of memory, which made them great for sequential data like translating sentences. After that, convolutional neural networks, or CNNs, became the absolute gold standard for reading images and video. And more recently, we got transformers, which use a special mechanism called attention to really grasp deep context in human language. To put into perspective why we need specialized networks like CNNs, just think about this massive number: 1 million. If you have just one tiny, standard colored image that is 1,000 by 1,000 pixels, a basic neural network would force a single neuron to process 1 million inputs all at once. That's just computationally impossible on a large scale. CNNs optimize this by looking at small patches of an image one at a time, finding edges and corners. It proves exactly why we need specialized architectures for visual data.
All right, Section 5. The Generative AI Revolution, Creating from Scratch. Let's dive right into the core of our nested universe, the explosive field of Gen AI that has literally taken the world by storm lately. Generative AI marks a fundamental, game-changing shift. Up until now, we've talked about models that analyze data just to classify it, like predicting if a loan should be approved. But generative AI uses large language models and natural language processing to actually talk to us and create original content. It doesn't just categorize, it autonomously generates brand new text, stunning images, fully working software code, and incredibly realistic audio, completely from scratch.
And here is a look at the modern Gen AI toolkit. You've probably heard of a few of these. These are the practical applications powered by those transformer architectures we just learned about. For text, you've got massive models like OpenAI's ChatGPT, Google's Gemini, or Meta's Llama. For images, we have tools like Midjourney and Stable Diffusion. We're seeing Sora and Runway for video generation, and software developers are heavily relying on GitHub Copilot to write code faster than ever before. It's wild. Which brings us to Section 6, your next steps in AI, building your toolkit. Because now that we've decoded the concepts, how do you, as a focused student, actually start building this stuff? Theory is great, but we need a practical roadmap.
So, here is your foundational career roadmap. Your absolute first step: master the Python programming language. It is pretty much the industry standard. From there, you're going to want to use libraries like NumPy and Pandas to clean and process your data. For your standard machine learning models, you'll rely heavily on scikit-learn. And when you are finally ready to build neural networks, start experimenting with PyTorch. It is heavily used in academics and is incredibly beginner-friendly. Or you can check out Google's TensorFlow. Grab some free datasets on Kaggle and just start practicing. To wrap things up, I love this quote from our source material because it highlights that AI isn't some dark magic. It's simply the beautiful math of teaching machines to recognize patterns. It's all about moving away from humans having to hard code every single rule and instead empowering systems to learn organically from the massive amounts of data we produce every single day. So after journeying through this entire explainer together, I want to leave you with one final thought. Which part of this incredible AI universe are you going to build your future in? Are you going to optimize delivery routes with machine learning, process visual data with deep learning, or maybe create brand new worlds with generative AI? The tools are out there, the roadmap is clear, and the next step is entirely up to you.
Thanks for exploring the AI universe with me.